Good. Hey, welcome everybody. Thanks for joining us today. My name is Adam Penna, and I'm here to continue the conversation in additive manufacturing and 3D printing. And very excited to have our guest today, Andrew McEwen, who is here from Altair, and wanted to talk a little bit more about, the side of additive manufacturing and 3D printing that gets into what's going on with actually simulation. And that's a part of designing for additive manufacturing, a big part of what engineers and designers can get into to make things better, and also to do it without getting a lot of waste, because you're able to do what it says and simulate things. So we'll talk a little bit more about that. But Andrew, welcome today. Good to have you here.
Thanks for having me, Adam. Yeah, really excited.
Awesome, man. So yeah, well, good to see you. And I know we have a similar past that's kind of crossed even paths. So good to have you here today. And I don't know that much about simulation. I've used it in the past, but the tools have changed over the years, and there's a lot of great things going on inside of simulation itself. And I know that's part of Altair's package. They have plenty of other things that they can dive into, but the side of it that you're working with and that we're going to talk about today has to do with simulation. So I'm glad you're here to talk about that and how it applies to 3D printing and additive manufacturing inside that process. But how have you been doing? How's everything been going with the last few months? I know we've all been dealing with things in this pandemic. How's life been going for you?
Yeah. I'm in the hot zone, I guess, down here in LA.
That's right. You're in LA. Yeah. How's that going?
Actually, pretty well. It's been an easy transition for the folks at Altair, because we've always had kind of this open policy of, if need be, work from home. I mean, this is all digital. We're in the kind of the software space.
Yeah.
So, through the power of Zoom meetings, GoToMeetings, we're able to connect with our clients wherever they are. So pretty natural transition there. We already had everything in place. Personally, it's a little bit of transition in the past few weeks because I have a newborn. So that's
wow. Congratulations. I didn't know that. Oh, wow. That's cool, man. Awesome. Congratulations. Really neat.
Interesting time.
Yeah. Well, good. I mean, that's, you have a lot going on then for sure. So thanks for taking a little bit of time and talking to me today. I know we were talking a bit about, our past and what we've done that's kind of been similar in our lives, working with, beginning with, engineering, CAD engineering, and kind of getting into the side of it of looking at what scan data could do in the beginning. And there's the scanning is thrown around differently in additive and other industries. Take, for instance, additive manufacturing, 3D printing looks at scanning, especially when they're talking about like laser powder bed fusion, where it builds layer by layer. The scanning is actually how they move the laser around the powder bed. And so that's good. They talk about scan speed and everything else that goes on with the laser at that point. However, what we're used to in more of the design sense is when we use lasers or scanning, we're actually collecting point clouds, collecting data, collecting surfaces of either existing or something out there we're trying to reverse engineer, or something we're trying to inspect. But yeah, then what we could do with that scanning data is really neat, and it's a lot of what ends up in the 3D printers. So that's neat. I know you have that background, worked a little bit in that at the same time I did. So how was that for you? Like understanding that background of you coming from engineering and then jumping into laser scanning and that whole world. How was that for you?
Really exciting. We're in kind of this niche space, and it's hard to get away from it, because there's so much that you see and that a lot of people get to be exposed to before products are developed, and you get to see how they're made and add value to those conversations. Yep. Yeah, I got my start in college looking for your first internship, right? And it's kind of, they're looking for experience and you're trying to gain the experience. And
that's a hell of a conundrum right there.
Yeah. Went before 3D printing was a buzzword. I worked for Z Corp reseller, and so you and I discussed how we had Z Corp scanners back in the day as well,
which were actually Creaform scanners, but
exactly,
I guess
right?
I just went there.
Yep. Yes, sir. But no, it was great. I was managing the services there, and then moved on to become an application engineer in the 3D scanning space. And you and I both know, I mean, you get to work with every industry there is: aerospace, medical, automotive, power gen, and it's really rewarding when you're able to, my whole thing was really helping to keep jobs in America. faster, cheaper, better, pick two. Well, I'm able to help you make better products, do it, more efficiently. So at the end of the day, yeah, it's saving jobs, keeping things local. And now I've kind of taken a step ahead of that. Before goods are manufactured, I'm helping engineers and designers figure out how to do that faster and make better designs before they even go into manufacturing.
No, that makes sense. I mean, everything that's going on, coming from that scanning world and the ability to jump in all those applications, and then now, pushing that forward, everything that we've been involved in, and be able to take that into any kind of realm and what we want to do and look at with different applications and helping them, improve, depending upon what sort of industry we get involved in. I know Altair, in general, great company. Everything I've run into them with, there's been always a very professional attitude and a very, consulting approach to the way they do things with their customers. So how has Altair been for you? Could you tell us a little bit about the company and how you jumped in there and what you've been doing over the last year?
It's amazing. So like I mentioned, I really enjoyed the 3D scanning space. My back didn't enjoy it so much, moving gear around, but
sure.
I always wanted to figure out what the next step was for me. And I had some colleagues that went into the simulation space, got pretty high up in the interview process, didn't work out. But 4 years later, a gentleman that was a VP remembered me and said, "Hey, I'm at Altair now."
Nice.
I didn't know anything about Altair, but I knew him, and I met the people, and I really joined based off the people and the idea that it's something I can get behind, right? Simulation, it could be anything. It could be making, brakes more efficient, making sure an airbag deploys, right? So you're making the world a better place. But Altair, I joined, I looked at the Glassdoor reviews and it had like a 97% approval rating of the CEO.
Yeah.
Majority of people would recommend to a friend. And the culture is just phenomenal. They're engineers first. Some people don't know of Altair, but it's publicly traded in the past few years. But yeah, a lot of it's just growing through word of mouth. People, move on in their careers to other companies and they remember Altair. But there's so much that we can do for engineers, between the actual simulation, but even the optimization, letting the software guide you to making a better design, even high performance computing. So you can really, get some horsepower behind you and crunch those numbers faster. And even, especially now during COVID, we also we're engineers staffing engineers. So
nice, yeah.
If a company is growing or vice versa, or somewhere in between, how we can help them. If they don't have engineers, we can place them on site. If they don't know how to do simulation, we can do services for them and then mentor them on how we did it.
Right.
So really
share the knowledge. Yeah. That's awesome. The whole side of it that Altair brings, to the market, enable us to focus on actually getting into what's happening in simulation, because when people think about simulation in general, sometimes they don't know what we're talking about, but it usually gets down to, what's happening with the actual part. The part's made of a material, the part has to be made a specific way. And then that part has to be used somewhere. So it's like, okay, inside of that application, inside of looking all those things, you get into, there's stresses involved, the materials react differently, you have different loads, different everything going on, that if you were to take something and make it and go put it on something and then test it, that would be kind of like your testing phase, which you do. However, a lot of that you could take back and look inside of software in the simulation stages. And I know plenty of software start to have the simulation built in, and I was used to that on the CAD side when I worked with, everything from UGNX to CATIA, and of course a lot of people have the most common software like SolidWorks or Autodesk out there, and they have simulation packages. But I know as far as what Altair does with HyperWorks, you guys really dive in a little bit deeper and have a little bit of different attributes and a lot of the same attributes, but you're doing things that are more specific towards applications and improving them. So, what can simulation do inside of DfAM, and what do you see as a lot of the benefits that are happening that can be used today?
Yeah, no, good point. So Altair has been around for a few decades now. We actually might be credited to kind of the first in the optimization space. And so optimization can be many things, right? We talk about simulation and optimization. Simulation is when we talk about it, it's not like an animation, right? It's not a, not that type of thing. It's taking CAD generally and applying physics to it to predict the real world outcome. And to do that, there's a lot of different factors, right? Because if you just say, hey, I take a block and I drop it, what happens? Well, like you mentioned, it depends on the material, depends on the temperature, depends on a lot of different things. So we get actually into the multi-physics, and then even beyond that, even the math and systems behind it, as far as like, what's the input if you have a whole system or systems of systems. The optimization side, when we talk about DfAM, generally what we're thinking about is lightweighting is the most
design. Yeah, design for additive manufacturing. Yeah,
and that really opens up the doors, right? Because there's so much we can do with 3D printing and different additive technologies now, where we can reduce material, and so the optimization software helps us really unlock that power, saying, okay, where can we reduce material or use a different material that will reduce 70% of weight, but still be structurally sound where we need it to, right? And it's still going to have the same mounting location, still going to fit into the space that we need it to. So design for additive, for us, it means a few things. One, on the design side, is actually developing a part designed for additive, but also we can simulate the printing process to figure out, will there be any issues? Because especially in metal printing, there's a lot of different factors. Parts don't always come out as you think they may. And that could cost you obviously material costs and time on some of these machines can get rather expensive with machine time. So we can actually simulate that process, as well as look at the support structures and figure out how much support material do we need? Can we reduce material there? Can we space out some of the structures? So in turn, again, reducing the material costs. So yeah, we're teamed up with all the major players within that space. Pre-COVID, I think the last trade show I was at the Anaheim Convention Center. It was MDM, PDM, all of them.
Right. Yeah.
But yeah, it's super exciting. Earlier this year, I was at a meetup group, and there was a few folks from Virgin Orbit and some other space players out there. And I think if I got it right, they mentioned that for 1 pound, it costs about $210,000 would cost to get to Mars. So if you think about a bracket, if I can reduce 1 pound, that's paid for itself. So
yeah, no, that's the whole trick in aerospace, obviously, with lightweighting. The more you lightweight, the more fuel you could save, and so on and so on. So that's an obvious kind of thing to go after, inside of aerospace. It's some of the other industries where it's not so obvious, where you get into simulation of stuff like liquids and gases, the flow patterns, what happens, what's actually going on. In additive, we're starting to see things like combustion chambers that have like internal cooling that actually has all of that built right inside of the walls. And just imagine how much that has to be really checked and simulated, obviously. And so the power to be able to do that, wow, what an advantage. It's pretty cool when you see those kind of things to be able to be made. You can't make that in any other way. So then to be able to do that, you got to actually be able to simulate it first, so you could see what the best pattern is, what you're getting out of that, and how you might be able to improve it. And you could look at that. And that's where I started to see simulation when I was working in CAD a lot more. It was like I was looking at flow patterns with HVAC and stuff like that. And it really started to open up my eyes of how I should maybe think of designing a different way that I thought would work,
Right.
But yeah, that's pretty neat. What are some of the cool applications you've seen? I mean, there's so many neat things. Is there anything you could talk about?
Yeah, right. That's the trick. Is there anything?
That's the bottom line.
Scanning, printing, in simulation. Generally, we're working with companies that are very competitive, right? And a lot of it's under NDA. But I would say, no, I have seen seen some things that have been published by NASA JPL. Using our software for lightweighting. Yeah. But in general, I think aerospace, I also love cars. I came from like 80% of my clients in my previous role at Faro were in the automotive sector.
Yeah.
Renault and some of the
Haven't
other.
even got into the Faro parallel with each other. That's awesome
Yeah,
too. That, you know, you worked
yeah.
there after I did, but we both are alumni there, I guess you could say.
Right.
Metrology world.
Yeah, exactly. Yep. So yeah, I think cars, like we've got some clients that are in the automotive space, you know, trying to just make these, you know, 6 supercars, and so like you mentioned, it's not just the lightweighting, it's also, hey, I can manufacture parts in fewer pieces. I can make them more aerodynamic using additive. So that's really interesting. Just reducing the amount of parts that are involved, and being able to put more in less space.
And that's a big thing, right? Put more and less space. I see a lot of that, you know, with heat exchangers. That's another thing that's out there. That's a really hot application right now. Obviously, with additive, you could build more in a unique and tight space than you can with a lot of the other traditional methods. So that cost per part analysis right now is going on in almost any company that's looking at heat exchangers and seeing what they could really, how they could benefit with the 3D printing process, because there is so much you could do to add surface structure, and that, of course, is the bottom line when it comes to heat exchangers. So, yeah,
Right.
a lot of neat applications out there for sure.
Yeah.
Yeah.
I can give you kind of a story, and it could be applied to anything, right?
Sure. Yep.
If you take the iPhone 4 back in the day, there was this thing called Applegate, right? Where if you put your finger in a certain spot on the phone, you didn't get signal, right? And so you look at it and think, well, how did that happen, right? It's like, was that not using simulation? But here's the thing: if you're an antenna guy and you put this in, even in a physical testing environment, and it looks, hey, that design looks great, and then there's another engineer who's working on a different team on the case. They do a drop test, all these different tests. It looks great, but what happens when you put the antenna, inside of a case? It
reacts differently. Yeah.
So that's where having the multi-physics, having all these different factors talk to each other is really important to get the real world outcome. So that's just what amazed me is I think of the general, FEA test, great, but then when you start to
FEA is the finite element analysis, just for people that might not know what that is.
Yep. Yeah. Right, absolutely. Yeah, and even if you look like a wing of an airplane, right, it reacts differently depending on the materials. So we can even get into designing different materials and different composites. That's all going to affect the outcome on how a part reacts in the physical world. And in my mind, that also, that especially as we near towards, get into kind of the Q4 different seasons, people traveling, hopefully.
Yeah, a little more.
When you travel, I would think about this every year, whether you're on an airplane, you're on a car, on a bus. Was this design, was this validated? Did everyone check that this is going to perform? Bridge, for example. And then also going back to the scanning side, did someone inspect this, right? And I always felt, great having the confidence of, yes, someone used a 3D scanner to validate this. And so I feel like in my small way, I contributed to that, right? I'm getting the hands of the people that can use it.
No, that's important. I think that's what it is about, actually. Both sides of the helping with the application. The end user, the client, gets the benefit, but you get the benefit of actually going through the process of getting them there and seeing them happy with the result, because they've actually, with the simulation process, simulated what could have happened and look at some of the issues and avoided them and mitigated some of the bigger risks in the design phase before you go and put that part somewhere where a bad thing might happen, so
yeah.
That's really neat. And you also brought up the importance of like the industry and the collaboration that goes on out there, when you're actually working with people. And that's one good thing. I mean, I like to focus on the positive. This pandemic is really horrible, and a lot of people are going through some very challenging times. At the same time, what are we finding as far as collaboration is going on? I see a lot more open collaboration. We can't go to each other's offices or to go to, visit a company as much as we used to. However, people are a lot more open to talking about certain things. So I see the collaboration side of it is starting to, even people that I didn't think would talk to each other are talking to each other more. And that's a beautiful thing. I think a lot of great things are going to start to come out of that. So I'm glad that Altair's out there doing things to help people collaborate. You know, that's a very important. And so over the last year, what are some of the important collaborations you have seen? You don't have to talk about the people, but maybe the industries and how things are being, bolstered up over the last year.
Yeah, I was just gonna kind of expand on that topic.
Sure.
Recently, what I found really, lack of a better word, joyful, is seeing people come together during COVID and using whatever tools they have to contribute. So I've seen a lot of different types of ventilators and different pieces that designed, and then printed out there. You mentioned earlier that the importance of simulation, being able to go through these tests, but it's not just validating, it's also helping explore different scenarios. Because I remember a gentleman saying, okay, my current process, I physically take this, and I drop it times or whatever, and I see, what happens. But the thing is, you can only drop that so many times in so many ways. What happens if you drop it from a different height, a different angle, right? If you throw it, and so simulation helps you make discoveries, in a shorter amount of time. And so, whether it be, an application for a ventilator or something else, it's just when time is of the essence, whether it's some sort of disaster or just trying to compete with time to market, simulation was help you crunch that, right?
No, that timeline you're talking about, right, is very important, because that's one of the biggest strengths of simulation is you could look at, I think the word is even fatigue, right? You look at the fatigue over so many, years from using it this way or that way. You could do that in a very, not years, but in, run the system analysis, you see how it comes out. It gives you a report on everything you would have been doing for years. So, and you would have been only doing it one way, and it does it as many scenarios as you want. And that plays into the iterations that designers go through, and people that are actually at the printer themselves. They have to go through design changes and iterations. And you could avoid some of that if you've taken it through a lot of those simulation processes. And so yeah, fatigue is huge, obviously, and a big cure is going through that simulation process. So yeah, I'm excited about it, man. It all adds to the industry. There's so many tools in the toolbox, and the pre and the post processing. We're talking about more of the pre-process of it going in the machine and what you actually go through. Even pre-design, you start thinking about the materials and what they're going to, what use they're going to be, how they're going to perform, what method you're going to use to actually do the manufacturing. And when you're able to enter all those things like the material properties that you could add into your simulation, software simulation, those are things that are invaluable. I mean, there's, how the heck did you even do that, 20, 30 years ago? It's speeding up the manufacturing process. And, 3D printers and additive manufacturing are speeding up most of the low volume manufacturing processes, but we're seeing it kind of get into a tipping point of, hey, what can you do? And that's where the additive manufacturing side, everything's starting to become a little bit bigger, a little bit faster, and you're starting to lessen that gap of, hey, we could do a lot more now than we could in additive just even 2 years ago, and imagine with everybody collaborating now and getting together and talking and it being more open. And also the urgency that we have in today's times of improving things locally, like you said. Wow, it all adds to that happening that much quicker with the right tools. So it's all exciting to me, obviously. Yeah. I'm drinking the Kool-Aid over here.
Yeah, for sure. I would also add that as far as how it's influencing industry is that, as mentioned with the kind of the Apple scenario, it's common that large corporations will have kind of operate different silos. You'll have, one team that works on this and then another team that works on that. And that could create a bottleneck as well, where they're not able to start their process until they've got kind of the input from the other team. We've got a really easy to use interface called Inspire, which is one of the platforms for the additive side and optimization side. But it really allows designers to kind of take it to another level, where instead of, again, putting in a design and then trying to simulate, which you can absolutely do, what you can do is start with the actual design space, right? And so you can actually say, okay, I'm going to design a part, needs to fit within kind of this envelope, and there's going to be, 3 holes here and here where something else is going to mount to it, and then let the software help you design within that space.
Yeah, like you're giving it the constraints that it has to actually build inside of and see what the software can do with the known constraints inside of there. Yeah, that's huge. And
because there's 2 approaches, right? There's having the software help you design the optimal part given those constraints. And then I've also seen in this industry where you kind of put in some values and it gives you 20 different options, and it's like, well, which one is which, right? So
right, and then like you're saying, you might have an option for 3D printing, you might have an option for casting, you might have the option for injection molding, any process that's out there, and one of them is going to be a little bit better, and it might be the choice you want to go with. And I thought I was going to use this on my 3D printer, but you know what? The actual results and performance are better going with the cast setup, so I'm going to do it that way. So you get to simulate the choices that you have also. That's huge. Good point. That's a big one. Yeah, so that's an advantage. We talked a little bit more about advantages. So, with HyperWorks and with Altair's packages, what are some of the advantages you have over the other softwares out there? Because it's a competitive field. What are some things you could point out that HyperWorks is above the others out there?
Yeah. So it was interesting when I came to Altair, right? Because I used to be, it's Pharaoh versus Romer. Pick one. We're going to battle this out. What is most important to you? And we'll figure out what's the best solution. With Altair, it's a little different, right? Because a lot of our clients are already using different simulation tools. But you kind of hit on it. There's so many different types of simulation, so many different tools out there. So if you're happy using an abacus solver, right, kind of the math behind what's going on, that's okay, right? But a lot of our clients might want to use a different GUI, a different preprocessor. So HyperMesh will work perfectly into that current workflow that you're used to. And so what happens is, once they become an Altair client, based on our token system, they can use those tokens for different things, right? And so really our business model is, solve a problem first, and we'll grow with you from there, right? Because we've got over 35 kind of tools within that HyperWorks CAE portfolio. We've got another 150 in our partner program that you get access to as well. Nice. So it continues to grow. So our thing is not to say, hey, you need to buy X, Y, Z. It's more, okay, what's your current workflow like? What are you trying to do? And we can try to figure out where we can add value there. And then the rest, through, just, rapport and keeping up to date, we can build that relationship and help you in the future, because you'll have access to those things. We don't even need to sell you on anything else. The way that Altair grows is when you say you have a colleague that wants to use those same tools, great, he can use them. He wants to use them at the same time as you. Okay, now you've got to buy some more tokens. So we only grow if we're actually helping, because also it's a SaaS model. So we don't get the renewal next year unless we're actually solving, helping solve problems. But yeah, HyperWorks, pretty much, it's not a question of if we can help you, it's how.
Yeah, you have to actually look at the actual process to see where it fits in. And if it doesn't, okay, but where it does, it really does, and it takes off. Yeah, that's all awesome stuff. I'm glad you're here today talking about it a little more, opening my eyes for sure, thinking about it a little more inside of the process. 3D printing and additive manufacturing, of course, could be used in so many other ways, and it is. So it's good to see you guys doing that. I know it's altair.com. Is that correct? Is that where people get in? It's altair.com/HyperWorks. Is that the direct link to the the actual software?
Yeah, we've got a lot of different ways you can access information. If you just go to altair.com, altair.com, that's the best way, because you can sort not only by products but also applications. So whether it's additive or you're looking at looking at electromagnetics or some other field, you can kind of get that tailored. And then of course, we've got a plethora of support options. So you can take a look at our, if we don't have an event today, we're going to have one tomorrow.
No, yeah, that's great. So it's a great resource to check out those events coming up. Yeah, that's what I'm saying. I'll go ahead and make a link into this conversation so people could check that out and look into it a little more. Andrew, it's been amazing talking to you today. You have anything else you'd like to add while you're here?
Oh no, it's just amazing, through the power of LinkedIn, especially in today's time. Happy to have this opportunity to chat with you, and I'm sure we'll see each other at the next show, hopefully in the future.
Yeah, hopefully sooner than later. The next event. That's a big thing I miss right now. Especially this is our season of doing that, meeting with colleagues and customers, and really kind of digging into what's new and what people have been thinking about and how the year's been. So, yeah,
yes.
I'm looking forward to getting back to that.
Absolutely. If I may add, I would just encourage anyone who's open to learning. I consider myself a lifelong learner. You never know where life will take you. Let's connect on LinkedIn.
Yep.
I've helped people that I connected with, 8 years ago, and they end up, in a different place, and stars align, and it makes sense to have that conversation. So, when it comes to professional networking, especially in the kind of the engineering space, I'm always open to meeting new people.
Yeah. Well, hey, it's great to have you here, Andrew McEwen, driving more design with simulation over at Altair and HyperWorks. Hey, thanks for being here, Andrew. You have a good day, buddy.
Thanks, Adam. You too.